Hey everyone, I'm going to be talking about how to go about finding the 6 trig functions if you're given either just a ordered pair or maybe 1 or 2 trig functions already. So here in the packet it says, given a point on the terminal side of theta, find the exact value of the 6 trig functions of theta. So this point we're given is 5, -2. So if we just imagine little unit circle right here. If this is 1, then say extend 5 out to here. -2 would be right there. So that's our ordered pair, 5, -2. And we can connect these. Might be a little sloppy. We got a nice little triangle right there. So here, let me just label these. All right, we can use the Pythagorean theorem to find the hypotenuse. So a squared plus b squared equals c squared. We plug in a as 5. 5 squared plus -2 squared equals c squared. 5 squared is 25. -2 squared is just 4. Equals c squared. So we get, let's see, 29 equals c squared. And then I won't bother with simplifying this radical. So c equals square root of 29. All right, so if we're looking for the 6 trig functions, then we've got sine theta. Let me label theta real quick. So that's our angle, or not a very good sign, but the Greek letter theta kind of looks like that. It's often used to denote an angle. So sine of theta, cosine of theta, tangent of theta. Then we got our inverse trig functions. So cosecant goes with sine. We got secant that goes with cosine. And cotangent goes with tangent. All right, so to find all these, just keep in mind the, structure of the different trig functions. So basically SOHCAHTOA, if you remember that. All right, so basically what this means, sine is opposite over hypotenuse. So let's write that as O over H. So our opposite side of theta is -2. The hypotenuse of the triangle is square root of 29. So that's just going to be the answer to that. I'm just going to leave it as improper because it doesn't really matter that much. You can switch it if you want, just multiply by square root of 29 over square root of 29. For cosine, that's going to be adjacent over hypotenuse. So adjacent over hypotenuse. The adjacent side of this angle here is going to be 5, and the hypotenuse again is square root of 29. So 29. Tangent is opposite over adjacent. Opposite over adjacent. And so the opposite side is going to be -2. Adjacent side is going to be 5. All right, so that covers the basic, kind of the normal trig functions. Now we're into the inverse trig functions, which basically you're just going to follow a similar process, but we know that cosecant is equal to 1 over sine. So basically what we can do is just flip the, how the fraction's oriented for all of the normal trig functions. So for cosecant, instead of opposite over hypotenuse, it's going to be hypotenuse over opposite. And so we're just going to get square root of 29 over -2. That's going to be our answer for that one. Secant is going to be a similar process. So 1 over cosine. And so we got hypotenuse over adjacent, which is going to be equal to square root of 29 over 5. And then tangent, or cotangent, is going to be tangent flipped, which I'm going to write that down here. So adjacent over opposite. That's going to be equal to 5 over -2. So that's how you figure out the 6 trig functions, just given an ordered pair. If we are given maybe like 1 or 2 trig functions already. So for this example, let's see, we've got cosine of theta, cosine of theta equals 2 over 3. And then we've got cotangent of theta is greater than 0. All right. So we can kind of think about our unit circle again. So cosine is going to be, if we can, cosine theta equals adjacent over hypotenuse. So the adjacent side we know is going to be positive because we have a positive 2 right there. So let's see. Adjacent side, so if we're saying, well, all right, let's not get ahead of ourselves. So adjacent side going to be positive 2. Hypotenuse is going to be 3. So the way I'm thinking about it, it's probably going to look something like this. And then, so adjacent is 2, hypotenuse 3, and then cotangent has to be greater than 0. So we know that tangent equals sine over cosine. So since cotangent is just that flipped, we know that cotangent theta equals cosine theta over sine theta. So basically what this is telling us is that sine and cosine have to be positive, because if either of them were negative, then that would mean that cotangent would also be negative. And so, yeah, this is telling us how we're looking to the right place, because it looks like our cosine right there, which is 2, is positive, and then our sine over there is also going to be positive. So how we can go about doing this is we've got the outline of our triangle right here. Let me just draw that a little cleaner. Not exactly to scale, but oh well. So 2, 3. So it's going to be, or that would be B technically. So we can find this using the Pythagorean theorem again, just like we did over here. So a squared plus b squared equals c squared. And so in this case, 3 is our c. We already know that. So 2 squared plus b squared equals 3 squared. So what this is telling us is b squared is going to be equal to 3 squared minus 2 squared. So we can work that out as b squared equals 9 minus 4. Just pretend that's a minus. So 9 minus 4 is equal to 5. So b is the square root of 5. All right, so now that we've got our triangle all figured out, we can move on to finding the 6 trig functions. So let's see if I can squeeze this in somewhere. Sine theta, cosine theta, and tangent theta. And then over here, you can say cosecant theta, secant theta, and cotangent theta. All right, so we start off with sine theta as opposite over hypotenuse. So opposite is going to be b, or square root of 5. Hypotenuse we know is 3. So square root of 5 over 3. Cosine adjacent over hypotenuse. So our adjacent side, saying theta is right there, because we're starting out just from the unit circle. So adjacent is 2, hypotenuse is 3. So that's 2 over 3. Tangent is opposite over adjacent, so the opposite side is going to be square root of 5 there. Adjacent side is going to be 2. So that's going to give us square root of 5 over 2. Cosecant, as we know, is just sine flipped around. So if we just flip this, then we get 3 over square root of 5, which you can make proper if you want to, but it's not a big deal. Secant, as we know, it's cosine flip, so 3 over 2, and same deal with tangent and cotangent, we're going to get 2 over square root of 5. Hope this helped you figure out how to, learn more about the trig functions or whatever, or pass your test, or do whatever you got to do. All right, thanks.